Hi, everybody. Thank you all for coming to our webinar today. This session is building the game analytics pipeline for faster, smarter decision making. So this is about a 200 to 300 level session where some previous knowledge of AWS analytics services would be beneficial. So to do a quick round of introductions, my name is Gina Gizzi. I am a solutions architect here, part of AWS Game Tech, and I'm here with my teammate Greg Cheng, who is also a game solutions architect. So first things first, what is AWS Game Tech? Well, whether you're a team of 1 or a team of 1,000, the most important thing to you is probably creating a game that players are going to want to play. How you get there is the real question, and that's where AWS Game Tech can help. Game Tech provides robust and scalable solutions for every stage of a game's lifecycle, whether it comes to the AWS services that we offer, or our Twitch integrations, or even our managed game services like Amazon Game Lift. So today we're going to talk about the demands of data analytics in games. So why do we even want to have a data analytics pipeline in the first place? We'll discuss some current industry challenges. And then we're going to highlight a solution that we created to address some of these industry challenges called the Game Analytics Pipeline AWS Solution. And then we'll demo some of the main components of this solution so you get a chance to see it in action. So first, let's talk about what the business value is of having a data analytics pipeline in your game. So here is Supercell's policy. So Supercell is a company that's well known for game titles like Clash of Clans and Clash Royale. They say that analytics can't make a hit game, but it can improve it. They say that analytics to them is very important to improve their games and keep their players. So they've been focusing on improving their analytics pipeline for a long time. They have free-to-play models where analyzing player spend, for example, is very important to them. So here are the high-level demands of analytics in games. We often see that having an analytics pipeline and getting insight from data can help you do things like create more engaging games, monetize your games, help with fraud and player investigations, as well as do things like performance monitoring and error reporting. So to dive a little deeper into each one of these, you can use analytics to create more engaging games by improving your game design and optimizing your gameplay experience. For example, if you instrument your game to emit game events, you can analyze data to reveal how your game is being played. Use that data to enhance your game design for better engagement. For example, let's say you instrument your game to emit telemetry data of where player deaths occur on a map. You can use this telemetry data to create a heat map or a visualization, which could be an overlay of a map design so that you can see where player deaths often occur on a level and identify opportunities to enhance that level design. The next is monetization. So you can use analytics to better monetize your games. So our users that play the most also spending the most on in-game purchases, right? So this is important depending on the type of model of your game. Is it a free-to-play game with microtransactions, or is it a one-time purchase? Well, with analytics, you can better monetize your game by doing things like segmentation. You can create models of your players or cohorts to understand where they are in the player life cycle. This in turn can lead to things like better recommendations, for example, right? You can also monetize your game to do things like encourage purchases. Maybe an XP boosting item is not very popular. With analytics, you can decide whether or not you want to buff it, or reduce the price, or just remove it entirely from your store. And then we have targeted ads. So things like doing reward videos. You can find out which of your players are prone to spending and provide targeted ads for other items or even other games that you develop. The next is fraud and player investigations. So you can use analytics to help detect and prevent cheating or fraud. Fraudulent behavior can often be very disruptive to the game experience. And from personal experience, it can ruin the enjoyment for other players, right? So it's important to have a plan so that you can understand when fraud happens and react quickly to avoid it having negative impact on your game. So with this, you can review how specific players behave in game and use that information to make changes if you detect this fraudulent or abusive behavior. So one example might be, can you possibly detect if a player's lateral movement defies physics? Well, then maybe they're probably cheating if so, right? The next is performance and error reporting. So you can use analytics to do things like monitor performance and error reporting, which can help with improving your game infrastructure by understanding important metrics like CPU and memory utilization. You can know when your peak usage times are and use these metrics to scale your infrastructure accordingly. Measure latency is another thing that you can do. So if you're developing a latency sensitive game, for example, like a first person shooter, you're probably going to want to measure the latency that your end players are experiencing so that they can have an optimal experience. And then finally, you can analyze error trends. So have logs streaming from your applications to proactively detect and prevent any errors that might happen. So here are some customers who are currently doing analytics on AWS for a variety of different use cases. So just to point out a few here, we have Epic Games, who hosts their data lake in AWS to analyze billions of events from Fortnite. We have Rovio, who analyzes billions of events per day with S3, Redshift, EMR, and third-party tools to do things like automatic level generation and level difficulty analysis. And we have Zynga, who analyzes streaming data from Words with Friends with services like Kinesis Data Analytics. The key thing to remember here, though, is that depending on the size and the maturity of your game studio, you might not have dedicated resources to help you set up and manage your infrastructure, or you might not have dedicated data analysts on hand with to help with getting insights or to manage a data analytics pipeline. And so setting this data analytics pipeline up might be challenging. So let's talk about some of the common challenges that we see across the games industry when it comes to analytics. So the first challenge is understanding what data you need to collect. And it really depends on the questions you have and the answers that you're looking to get. So we've been able to categorize this into two different types of data. We have user data and performance data. So on the user data side, we have things like player analytics. So this is all of the data that is used to help understand the player as a customer, right? So things like their purchasing behavior, how frequently they're engaged with your game. We've got social and community data. So this data helps you understand how players interact with other members of the player community. And then we have gameplay data. So this is all aspects of how a player actually plays your game, like their in-game behaviors, what levels they spend the most time on, which items they use the most, and more. And then on the performance data side, we have wait times and delays, right? No player wants to wait around in a matchmaking lobby for 20 minutes. Network performance and latency. So if you're developing a latency sensitive game, such as a first-person shooter, you're going to have to pay close attention to the end user latency that players experience. And then finally, application logs and bug reports. So when you experience errors or bugs, you'll want to have a way to analyze this and remediate the issues as fast as possible. So ideally, you want to collect all of this data and more. So understanding what data to collect and how to collect it is the first challenge. The second challenge is that the data that you decide to collect has a shelf life. That means that the older data becomes, the less useful it is in helping you with timely reactions. So again, it's really important to consider the questions that you have and the type of answers that you want to know to understand when is the best time to look at your data. So to address this, there are typically two different types of data analytics pipelines, that we call batch and real-time pipelines, that allow you to get insights at different speeds. But with this comes the challenge of managing data at different speeds. Next, it's important to understand the four main components that make up an analytics pipeline. So there is the ingest/collect phase. So how are you going to ingest your data in a timely fashion from all of your different players? Next is store. Where and how are you going to store all of your data? Is there going to be PII information? How are you going to organize this data? How are you going to secure it? How are you going to process and analyze your data? What tools are you going to use? And finally, how do you visualize your data to get useful insights for your game, both for batch and real-time data? At its core, analytics for games are similar to analytics for other applications in different industries. You measure and track data elements to monitor performance. You understand customer satisfaction and monitor sales and so on, right? But what differs is, depending on the size and the maturity of your game company, analytics might not be a core competency. We're seeing games generate more data than ever. You might not have a data analyst expert on staff to implement an analytics pipeline and manage infrastructure. You might not have dedicated resources with knowledge and skills to perform complex data processing and analysis. Another challenge is that many of the off-the-shelf solutions can create data silos, and they also lack flexibility, which makes it hard to do things like centralize your data. So that's why today we are going to walk through a solution that addresses all of these challenges and does it in a way that's serverless, so you don't need to rely on a dedicated team to manage infrastructure for you. So I'm going to pass it off to Greg to present our game analytics pipeline.
Now I'm going to review the game analytics pipeline solution. The solution helps game developers launch a scalable, serverless data pipeline to ingest, store, and analyze telemetry data generated from games and services. The solution supports streaming ingestion of data, allowing users to gain insights from their games and other applications within minutes. In this section, I'm going to review the benefits of using the game analytics pipeline, the main components that make up the solution, and the flow of data through the pipeline using the solution's reference architecture. And first, we have the benefits that can be gained by using the solution. The pipeline lets you ingest and store data at scale. The solution is backed by Amazon Kinesis data streams to ingest real-time data durably at a massive scale. It also uses Amazon S3 to provide the core storage of analytics data and comes with built-in tiering, making it the most cost-effective and scalable place to store large amounts of data. It also provides the most flexibility for customers to integrate this data with the tools that they want to use. The pipeline allows you to analyze data with flexibility. The solution deploys AWS Glue to provide a data catalog which provides structure to the ingested data. You can access and analyze this data using the tools of your choice. The solution starts you off with Amazon Athena and Amazon QuickSight, but you can use whatever third-party analytics tools you want by using the Glue data catalog as a drop-in replacement for your external Apache Hive Metastore. Finally, the pipeline allows you to easily deploy and customize the solution. The Game Analytics Pipeline CloudFormation template automates the setup and provisioning of all necessary services for the solution. You can use it as is or you can download the source code from GitHub to extend and customize the solution as needed. And now we're going to review the major components of the solution. For streaming data ingestion, the solution allows you to collect real-time streaming data by sending all events to an Amazon Kinesis data stream, a massively scalable and durable real-time data streaming service. It can scale to ingest gigabytes of data per second from hundreds of thousands of sources, such as game clients, backend servers, and more. Next, we have real-time stream analytics. Here, an Amazon Kinesis data analytics is used to generate custom real-time metrics and alerts with streaming SQL queries. A Lambda function then publishes these metrics to a monitoring dashboard in Amazon CloudWatch. These dashboards empower your LiveOps teams to monitor the health of your game in real time and allows you to immediately react to issues or events. Next, we have data lake integration. Here, Amazon Kinesis Data Firehose processes the data by both enriching and validating the incoming data. It then delivers game event data to the serverless data lake backed by Amazon S3. S3 is used for long-term storage in an optimized format for performance and cost efficiency. The AWS Glue data catalog acts as a central metadata repository, allowing you to analyze the semi-structured data with any compatible analytics software. The last component is the reporting and visualization component. You can interactively query and explore event data in Amazon S3 with Athena, QuickSight, or other tools. Amazon Athena lets you run ad hoc analytic SQL queries on your processed data. Amazon QuickSight lets you create BI visualizations and insights with an easy-to-use drag-and-drop model. These services enable you to gain insights on your game's performance from a business perspective as well as a game balance perspective. Now that we've reviewed the components, we will now walk through how data flows throughout the pipeline. And first, we have the data producers. These can be mobile game clients, matchmaking servers, game consoles, multiplayer servers, and anything else that generates data that you want to capture. These data producers send their telemetry data into the Kinesis data stream, which stores your real-time data to be processed by the other components in the solution. The solution includes an API that is used to register new applications with the pipeline as well as ingest data from the data producers via the API if desired. If data is ingested via the API, the solution API allows you to create API keys to authorize applications to publish events to the API's events endpoint, which stores these keys in DynamoDB. The solution API forwards ingested data to the Kinesis data stream. The Kinesis data stream then sends this data to a Kinesis firehose. A Lambda function connected to the firehose pre-processes the data by both enriching and validating the incoming data. Once processed, the data is batched and stored into S3. Here, the data is stored in Apache Parquet format to allow for efficient and performant analytic queries. AWS Glue provides the data catalog, which stores the metadata such as table definition and schema. And it also creates a Glue job to partition the data to make queries more efficient. In order to gain insights into the processed data, you can use Athena to run ad hoc SQL queries using the included sample queries or by writing your own. You can also use QuickSight to create dashboards and visualizations to interpret your data and then embed these dashboards into your applications. On the right side of the architecture, we have the consumers of the processed data. Data analysts can look at QuickSight dashboards to monitor KPIs such as total revenue per day. Data engineers can use Athena to write more complex queries to assess KPIs like average revenue per daily active user. For streaming analytics, we return to the Kinesis data stream that sends events to Kinesis Data Analytics, a service that provides an easy way for customers to generate live KPIs. The solution deploys KDA for SQL to reduce the barrier to entry, but can be easily replaced with KDA for Java for customers that have more advanced streaming analytics use cases and experience with Apache Flink. The application generates real-time metrics such as logins per minute, registrations per minute, purchases by country per minute, and more. If you have a game that has a live ops team and want to create real-time alerts and metrics, then this feature is for you. However, if you're just focused on analytics, then you can deploy the solution without this component enabled. These metrics are post-processed by a Lambda function and published to a CloudWatch dashboard. These dashboards can be monitored by LiveOps and service teams to ensure that your game is healthy from a balance and operations perspective. You can also create alerts based on key metrics and send out these alerts with Amazon SNS. And now that we've reviewed the architecture and the data flow through the pipeline, Gina will walk through how to deploy the solution in your own account.
So now we're going to demo the game analytics pipeline to show you how you can get started with it, to deploy it, and to showcase some of the different features that it comes with right out of the box. So here's the landing page of the game analytics pipeline. So it gives you an overview of what the solution is, and it will provide you useful links like this deployment guide right here, which walks you through how to deploy the solution step by step, or this developer's guide, which will provide information about how to actually customize and extend this game analytics pipeline solution for your specific use case, as well as things like a link to all of the source code, which can be found in this GitHub repository, which we will need to refer back to later on in this demo, and the CloudFormation template link. And it will also show you the architecture of the actual solution that you are deploying. But what we want to do to get started here is just click this Launch in the AWS Console button. So when we click this button, it actually will bring up a tab of CloudFormation in the AWS Management Console. And so it will automatically link to the exact CloudFormation template that we need. So there's no need to specify a template because it's already specified for us. Then we click Next. We have to give the stack a name. So let's just name it Game Analytics Pipeline. And then here are all of the different parameters that you can configure. So the first one is enable streaming analytics. So this allows you to optionally deploy a real-time streaming analytics application that uses services like Kinesis Data Analytics for running SQL queries, and Lambda and CloudWatch to generate and visualize live metrics. The next one is Kinesis Stream Shards. So this allows you to configure the number of shards to provision for your game events Kinesis data stream, which is used for data ingestion. Then we have Solution Admin Email Address. So this is an email address that you can optionally provide to receive operational notifications from CloudWatch. And then finally, we have Solution Mode. So here we can choose if we want to deploy this solution in a dev environment, or in a production environment. So the main difference here between dev and production is that the Kinesis data firehose buffer interval is 1 minute in dev and it's 15 minutes in production mode for when you're actually batching your incoming data. So we're just going to leave all of the configurations default and hit next. And then we can take a look at some of the other advanced options if we like, but we're just going to leave everything as default for now. Hit next again. And you just want to make sure that you scroll all the way down to the bottom here so that you have to select these 3 checkboxes that you do acknowledge that AWS CloudFormation might create IAM resources within your AWS account. And then finally, you just click Create Stack. Now, for the purpose of this demo, I already went ahead and I configured this CloudFormation stack ahead of time because it does take about 10 to 15 minutes to actually successfully deploy this solution. And so you can see this stack here in my AWS account. It's the Game Analytics Pipeline stack. So if you click into this, you can see some of the different some information about this stack. So specifically, we want to focus on the outputs that are generated from this. So if you click this Outputs tab at the top, it will list all of the different key and value pair outputs that are generated from this stack. And so you can see things like the name of the S3 analytics bucket where all of your data is going to be stored, or the name of your Kinesis stream. So specifically, we're going to need to look back and reference the game events stream later on and the test application ID next for the very next part of this demo. So next, what we're going to need to do is open up a Cloud9 environment. So I will type in Cloud9, and I'm actually going to open this up in a new tab just so that I can look back and reference these outputs later on. And we'll walk through how to create a Cloud9 environment really quick. So you start at the landing page and you click Create Environment. And just a quick overview of what Cloud9 actually is. It's a cloud-based integrated development environment, or IDE, that lets you write and run and debug code all from within your browser. And so we're going to just provision a Cloud9 environment so that we can run a sample Python script that this solution provides actually in the GitHub repository to generate sample events for testing and simulating data. And so all you need to do is give your Cloud9 environment a name. So I'll name it Cloud9 Game Analytics. You can optionally choose to provide a description. Hit next step. Here are some of the different configurations that you can make, like choosing the instance type of the underlying EC2 instance that your Cloud9 environment actually exists on, or the operating system. And finally, you just want to hit Create Environment. Again, it takes a few minutes to actually set up and provision your Cloud9 environment. So for the sake of this demo, I had already set up an environment that we can see here called the Game Analytics Pipeline environment. And so all you want to do is click Open IDE, and it will open it up in a new browser. And so here we can see all of the files within our environment, and it gives us a nice place to run commands. And so what I did here was I followed the developer's guide to actually set up this environment. There's a couple of different commands that you need to run. And the main command that we need to run to actually simulate fake data is this one right here. It's Python 3 publish data.py, which is a script that the solution actually provides for us that's found in the GitHub source code repository. So we download that file, we upload it into our Cloud9 environment, and then we run that file, and we have to set some configurations like the AWS region that we're operating in, which in this case is US East 1. We have to configure the stream name and the application ID, which are both outputs from the CloudFormation template that we spun up right before this. So if we go back to our CloudFormation stack, we can find the outputs that we're actually looking for. So here is the game event stream. So we're looking for the value of that, as well as the value of the test application ID. So what I did was I copied those and I inserted them into the command, and then all you do is run this command, and then it will start generating fake data just for to simulate this. And so that's all you need to do to deploy the solution and to start simulating data.
Now that we have ingested data into the pipeline, I'd like to do a deeper dive into the data ingestion process in the solution. So first we have our streaming data ingestion methods, and the solution will ingest game event data by either submitting data to the Kinesis data stream directly or by sending API requests to the solution API, which will then forward the requests to the Kinesis data stream. You can integrate directly with the Kinesis data stream by using one of the supported methods in AWS. Depending on your requirements, you can utilize Kinesis agents, the Amazon Kinesis Producer Library, or KPL, the AWS SDK, or any other supported Kinesis integrations. If you require custom REST proxy integration for ingestion of game events, you can use the Solution API. Applications send events to the events endpoint, which synchronously proxies the requests to Kinesis data streams and returns a response to the client. We suggest that you only use the Solution API to ingest events if sending events to a REST endpoint is a hard requirement for your application. Otherwise, we suggest integrating directly with the Kinesis data stream for cost savings and reduced complexity. Now I'd like to go over the rest of the data ingestion process. And first, we have our two ingestion methods that we just reviewed. And once the game event data is stored in the Kinesis data stream, a Kinesis data firehose will consume this event data in real time and will trigger an AWS Lambda function for event preprocessing. The AWS Lambda function does two things when it's preprocessing the data. First, it uses the Glue data catalog to validate the schema of the incoming event data, and then it also enriches the data by adding additional fields and metadata based on the ingestion process. Once the Lambda function is done preprocessing the data, Firehose will load this data into S3, and it will load this data in a compressed Parquet format for optimized query performance. Now that we've gone over the data ingestion process, I'd like to go into the console and show you what this looks like in action. Now that we're in the AWS console, we can review the different components that make up the data ingestion portion of the solution. And the first service we're going to look at is Kinesis. So we're going to go to the service tab in the top left, type in Kinesis. We can navigate to the Kinesis console. Once we're here, we can go to the left side and click on Data Streams. And here we have the data stream that is generated by the template. If you remember from the previous demo, we replaced the stream ID in the demo script with the name of this data stream to make sure that that demo script would send events to this stream. So we can click into the name. We can click into monitoring. If we scroll down to the put records metrics, we can see that we are successfully ingesting data into the Kinesis data stream. So now that we know that we do have data in the data stream, we can go over to the Kinesis Firehose to check on those configurations as well. So we'll go to the left side and click on Delivery Streams. Here we have the Firehose that was spun up by the template, and we can click into the name to get more details. We scroll down. We can see here that the source of this Firehose is the Kinesis data stream that we were just talking about. This next section talks about transforming the records as they come into the firehose with an AWS Lambda function, which is named here. And if you remember, this Lambda function does two things for preprocessing the data. It both validates the schema and it enriches the data with additional metadata. This next section talks about converting the ingested data and outputting it in a different format. Here we can see that it is Apache Parquet, and remember this is the compression format that enables more optimized analytic queries. And finally, we have our S3 destination configuration. So the firehose will be loading the data into this analytics bucket, and it will be loading the data into this bucket with this prefix. This prefix is a Hive partition compatible prefix, so that's why we are using this configuration. Now, similar to the Kinesis data stream, we can go to the monitoring tab of the Kinesis data firehose to make sure this is working appropriately as well. As we can see, we are reading data from the Kinesis data stream. If we scroll down, we can see that our Lambda function is also preprocessing the data as expected. So now that we've reviewed the firehose configurations, we can look at where the data is being loaded within S3. So we can go back to this Details tab, scroll to the bottom, and we can click on this S3 bucket link to take us straight to the bucket. Now that we're in our S3 bucket, we can go to that prefix that was noted in the configuration of the firehose. So here it is in raw events, and then we click through the rest of the Hive partition prefixes. And here we see our data loaded in batches in that Parquet format. Now that we've reviewed the data ingestion process and see that the data has landed in S3, next Gino will go over how to get analytic insights out of your data by running SQL queries as well as creating visualizations with both Amazon Athena and Amazon QuickSight.
So now we're going to showcase how you can do visualization and reporting with the Game Analytics Pipeline solution. So first, I want to do a deep dive on the architecture for the visualization and reporting part, specifically for analyzing batch data. So this is split into two main components. So first is where we have all of our data sitting in Amazon S3 once it's been ingested. And then what we're doing here is we're using AWS Glue, which is a service that allows you to catalog your data and perform ETL or extract, transform, and load in a serverless fashion. So here what we're doing is we're using a feature of Glue called the Glue Data Catalog, which provides persistent metadata storage of game events, and it also easily integrates with other AWS services, which is nice. And the second component is where we use services like Amazon Athena and Amazon QuickSight for the visualization and reporting part. So Amazon QuickSight is our business intelligence or BI service that allows us to create visualizations to get useful insights for our game so that our end users can pull value out of the data that they're collecting. And Amazon Athena is a serverless service that allows us to run SQL queries on data that we have sitting in S3 on an ad hoc basis. So now let's take a look at what it looks like in the AWS console. So now let's take a look at what this visualization and reporting actually looks like in the AWS Management Console. So let's start with Amazon Athena, again, which is our interactive query service that makes it easy to analyze our data sitting in Amazon S3. So if you click Get Started, you can see that on the left-hand side here, we can choose our data source and our database. So first, we want to select the database that was created by our CloudFormation template that we spun up when we launched this game analytics pipeline, which is called our game events database. So make sure to click the game events database. And then here we can see that we can write and run SQL queries, and then we can see the results on the very same page. So if we take a look at what some of the schema looks like of the data that we're actually sending, let's do a select star and preview our raw events table. So we can see that when we select all of the data from this database, in this case we're limiting it to 10 results, it returns some of the results in the same window, and we can see what the schema of our data actually looks like. So we can see that it's returning event ID, event type, and event name, which could be different events that happen within your game. For example, if a user logs in or if a level has been completed, we want to make sure that we're logging that and sending that data to AWS. We can see the event timestamp, so a timestamp of when that actually happens, as well as other information like client ID, user ID, session ID, and more. So something that I want to point out here is you can also send unstructured data in the form of JSON, for example, like you see here in the event data section. So we're just sending sample JSON data that's related to the events that happen in our game. So something else that you can do is run sample queries or saved queries that come out of the box with this game analytics pipeline solution. So for example, if we go up here and click saved queries, we see a list of all of the different sample queries that are already created for us that come right out of the box ready to run. So we can see here that we can get things like daily active users or total events or new users last month and so on. So if we ran a sample query, let's do the level completion rate. So this shows a rate of completion for each of our different levels. So we double click this and it will open up a new query in our Amazon Athena console. We can see what the SQL looks like and we can run this query, which will return results. So here we can see that we have 5 different levels and we can see the level completion rate for each one of those, which is just a percentage of completion for those individual levels. So for example, we see for level 1, it has about a 33% completion rate as compared to level 5, which has the highest completion rate of them all, which is almost 80%. So this is an example of what you can do with Amazon Athena. So now let's take a look at Amazon QuickSight. So if we click the drop down and we type in Amazon QuickSight, let's open this up in a new tab. So this is, again, our business intelligence tool that allows you to create visualizations to get useful insights for your game. So what we're going to do here is just create a new analysis. And we're going to choose a new data set. And here are all of the different options of data sets that you can choose from. But for our use case, since we just used Athena, we're going to choose the Athena data that we were working with. Enter a data source name. So I will just call it Game Analytics Pipeline. And this is important. You want to make sure to switch your Athena work group so it defaults to primary, but when you actually launch the Game Analytics Pipeline solution, it creates a dedicated work group for you. So you want to make sure that you switch there and click Create Data Source. Now select your database. So we want to make sure to choose the game events database that we have selected. And let's choose raw events and click select. We can choose to import to Spice for quicker analysis, but in this case, we're just going to directly query our data and then choose visualize. And in a couple of seconds, we'll see that we have this nice interactive UI that we can use to create visualizations with the different data. So we can see all of the fields that we have here. For example, here's event data, which again, we saw in Athena was that JSON that's sent. With a lot of different data within that JSON. So what we're going to do here is we want to analyze some of the event data that was stored in that JSON. So how we extract data from that JSON variable is we're going to create a calculated field. So you click add calculated field. We're going to name it map ID because that's the value that we want to extract. And then for formula, we're going to insert this parse JSON event data so that we can actually parse through this JSON and extract the map ID, which is the data point that we're actually looking for. You click create. And now we can see that we have our map ID variable. And so let's choose pie chart and let's choose map ID. And in a few seconds, you'll see that a pie chart automatically creates with our map ID. So let's just really quickly exclude null here so that we're only looking at the data points that we want to look at. And now we can see a distribution of our map ID. So which maps are the most popular here? Is the airport map more popular than the warehouse map? This helps us understand our map popularity. So this is just one example of a graph that you can create with QuickSight. So if we take a look at some of the other visualizations that you can create in a QuickSight, just for example, here we have again our map ID, which is map popularity. We can also take a look at match type popularity to see which match is the most popular amongst our players. So for example, here we have team deathmatch or capture the flag or 1v1. So in this case, we can see that 1v1 is the most popular match type and team deathmatch is the least popular match type. And then here is just a visualization of that level completion rate query that we actually ran and looked at in Athena. So this is just a nice visualization that clearly shows us that level 1 has the lowest level completion rate as compared to level 5, which has the highest level completion rate. So this can give us some insight into our level design and can help us answer our questions about this so that we can take this as an opportunity to iterate and improve our level design. So now I'm going to pass it off to Greg to conclude this webinar.
Now that we've gone through the content of this session, here are some key takeaways that we want you to leave with. You can use analytics to make fast, well-informed decisions to do the following. Increase engagement. You can understand where players are getting stuck or focus on improving the most popular game modes to keep your players coming back for more. You can use analytics to grow revenue. You can track the most popular items in the in-app store as well as your players' spending habits to ultimately increase revenue in your games. You can use analytics to improve your infrastructure. Based on the telemetry data sent from your game servers, you can make changes to your backend to improve the player experience. Finally, you can use analytics to identify fraud. You can find anomalies within your data to expose cheaters and prevent those malicious actors from ruining the experience for the legitimate players. You can understand what data to measure and what data shelf life is. You can now determine what key performance indicators are important to you and what data is required to capture to find those answers. Finally, you can understand how to launch and use the game analytics pipeline solution. Now that you've seen how the solution works, you can try deploying it in your own environment. So what is the path forward after this webinar? First is understanding more about what AWS Game Tech has to offer. And with this, we have the Game Tech learning path. Game Tech has a games dedicated learning path that organizes all Game Tech courses into one place. Whether you're a solutions architect, a game developer, a data engineer, or a data analyst, this learning path provides structured guidance on where to begin your training and the next steps to gain expertise. Next, we have experimenting with the Serverless Game Analytics Workshop. This hands-on training lab will prepare you to integrate the Game Analytics Pipeline solution by getting you familiar with the services necessary to build, test, and deploy a serverless analytics pipeline. In this workshop, you will create a serverless analytics pipeline and integrate it into a Unity game. The focus of this workshop is to build an entirely serverless solution for both real-time and batch analytics so you can analyze game data as it comes in as well as over a period of time. The architecture for this workshop is very similar to the game analytics pipeline solution. And finally, you can integrate the solution into your own environment and your own workloads. The AWS Game Analytics Pipeline solution can be found at this link, and the landing page for this has all the assets required to deploy and operate the solution. These assets include a reference architecture, an implementation guide, a developer guide, and links to the GitHub source artifacts. The solution includes a CloudFormation template to get your pipeline up and running quickly. Thank you everyone for your time and for joining us in this session.